All right. Once again, welcome. So today, class overview. Main thing for me is that this class is a difficult class to teach. And I don't mean to lower the bar for what I'm talking about, but I mean in this way. In what we're trying to accomplish is teach Bayesian statistics and apply them to psychometric models. And each of you has a different entry point into the world that we're going to talk about, right? Some of you have seen Bayesian or worked in Bayesian. Kaylee's done type equals Bayes before. Sergio's taken a Bayes class before. Ryan has a PhD, those types of things. So each of you may have a different background. And even if you've never seen Bayes before, that's great too, because I want to teach you how to use it. But then there's the psychometric models, right? Because those get very complicated. And as we get through the rest of the year, we're going to see that the interplay between Bayes and psych, Bayesian will get a little bit more interesting, psychometric models will get more interesting, and so forth, right? And so in some ways, this is like two classes in one, and in some ways, it's not even a single class. But it'll be hopefully enough to give you, at least when you leave this class, I hope that you'll be able to not be able to code up any model in Stan that we talked about, but even then have enough skill to take what you learn in Stan and apply it to other models that may not be psychometric, multi-level models or otherwise. Actually, if we have time, I'd love to do some multi-level work in here as well too. There's not much difference, believe it or not, between multi-level models and psychometric models. In fact, psychometric models are a type of multi-level model. You can call it that way. So, on that note, let's talk about some of the nuts and bolts of how do we do class this year. The first thing I'm going to do is go to the class website. So if you go to jonathantemplin.com, you can find my website. Scroll on down. The bottom link is our course website. This page should have all the information that you need to understand what's happening during the semester, what's going on during the week, and what assignments are due. Additionally, you have our Zoom link to our class recording or meeting, and we have my office hours link as well. Actually, on that note, I already see a typo. My room is actually 300A in Linquist Center, and I'll change that after the class. It's hidden up on the third floor, but I seldom am on campus. So if you would like to talk to me outside of class, I do have online office hours from 10 to noon every Wednesday. You can just drop in anytime. That's my personal Zoom room right there. Please do join me if you have any questions. Alternatively, if you shoot me an email, be happy to answer any questions that you might have as well. Vladimir looks like he has office hours from 9 to 10 Wednesdays, and then 10 to noon on Fridays. And Vladimir, you're planning on being in N476 in Linquist Center and on Zoom,
Yes.
correct? Excellent. But both of us will be responsive over email. I will try to reply to any email within 24 hours unless it's on the weekend or a holiday or something along those lines, where I try to do less email communication. But happy to chat anytime. I cannot encourage you enough to come join me if you have questions about anything. Okay, so class is always on Zoom. Office hours are always on Zoom. The next part of this is, let's talk about our syllabus first. Actually, let's do a syllabus. So the syllabus is here, and this syllabus will be fairly static. For the most up-to-date information about the class as we change, just take a look at the course website. It's basically going to take the place of the syllabus. But the syllabus gives you a lot more detail about the nuts and bolts. So we are going to cover Bayesian statistics in general. Our first couple weeks of the class will be Bayes, but applied to a linear model, like a regression ANOVA and ANCOVA analysis. So basically, I'm assuming that you have a fairly strong grasp of linear models, and so I'm going to take something that you may not have a grasp of Bayes and put them in a context that you hopefully have a little bit more knowledge of, and then we'll switch over to psychometric models and do Bayes and psychometric models as well too. We'll begin with confirmatory factor analysis, go through item response theory, do a little latent class models, Bayesian networks, diagnostic models. We'll cover things like Bayesian model fit, Bayesian model comparison, These are all important aspects of the Bayesian experience, actually any analysis experience as we go forward. And if we have time, I'd love to get into multi-level models and multi-level psychometric models as well. If we don't, I have a bit of material that I'd be happy to share with you that's on my website if you'd like any more of that. And I will say, I will try to start class right at 9:30 every day. So, if you don't show up right on time, of course, I'll let you in the room. That's not a problem. This is not a physical classroom where people will be interrupted by the door slamming or things like that. But I'll just let you know that I plan to start right on time at 9:30, so you can plan accordingly. I know some classes have this weird late spiral, which is, well, I'm not going to start till most of the people are there, so most of the people don't show up until a little bit later. So so we have this sort of class late time creep that goes on. We don't have enough time to cover everything this semester, so that's what I'm going to get through. So I will have a textbook, but it's open access. It's free. Pardon me, not open access, but we have an ebook for it. I didn't make you buy it. I don't know if you want to buy it. The textbook there's some chapters from it that I assigned. It's Bayesian Psychometric Modeling by Roy Levy, who's at Arizona State, and Bob Mislevy, who had been at ETS and University of Maryland for quite some time. I would call the book, if you are somewhat knowledgeable about Bayesian, the book probably won't help you much. Whereas if you're learning Bayesian, the book might be pretty helpful in terms of understanding some of the basics and so forth. I do intend that most of the class will be from my lectures and from the homeworks that we do, which I'll get to in just a minute. So the book is more of a reference, but I do think if you are new to Bayes, I strongly encourage you to read the book as you go along. The other thing about the book is it is entirely in JAGS. So if you want another program, or you want to see how to implement these models in that JAGS program, the book will also give you that information. Questions? Anything so far? No problem. All right. So, big question that I have is, how long are things going to take to be taught? So I don't actually have a schedule, because all I would do with that schedule is just constantly update it. So it's sort of like, is it really a schedule in that place? But here's sort of the topics I intend to cover as we go through. Some of the so in Bayes, so again, remember there's these two big parts, Bayesian and then psychometrics, the first two words of the title. In Bayes, we're going to talk about some foundations, some estimation methods, convergence diagnostics, what that means for Markov chains, model fit using posterior predictive checks, actually model fit using model comparison methods, in this case, leave one out sampling, or the widely available information criteria, WAIC, how we can build those into STAN as we go and execute our algorithms as well too. Actually, I will not have Argon for estimation. We'll actually use the notebook site for most of what we do, and I'll show you that in just a moment. Our IDAS Interactive Data and Analytics Service here on campus has a notebooks site for this class. I'll cover a few of these MCMC algorithms as we go. I don't know how much we'll go into this, but if any of you would like to know more about the algorithm, more than happy to talk your head off about it. Some of the main ones: Gibbs sampling algorithms, Metropolis Hastings algorithms, and something called Hamiltonian Monte Carlo. The last one you can really impress your friends. It's like Hamiltonian physics involved in this algorithm, which is kind of fun. Be like, oh, I'm doing Hamiltonian physics, right? I don't know if that really makes sense in the College of Ed. All right, and then in psychometrics, we'll get into what are methods. Actually, Kaylee, these are casino games. Some of these are actually, if you get into the history of statistics, right? You've got Bernoulli, I think Laplace. Both of them talked about statistics in roulette tables, right? How to play the game of roulette. So, yeah, a lot of very similar things. But now let's get into the psychometrics. We'll talk. I mentioned CFA, IRT, model fit, options for polytomous models, binary models, and so forth. Structural equation models as we go on. Sergio, to your question, I had a. Thank you for reminding me. Yeah, so I always teach this statistics to people who don't want to learn it, with saying, so how many of you go to the casino? And then how many of you drink beer, right? Well, so like the two biggest influences, not biggest, but very big influences to start statistics. There were the gambling influence, right, as I just mentioned. And then there was this whole t-test. Remember the students' t-test? That came about to sample beer at Guinness Brewery, right, to see quality control, I think it was. So Like, what other field gets its root from gambling and booze, right? I mean, like, if you want to have a good time, you study statistics, I think. Or data science. I think that's how we call it these days, right? Is that where you're looking for, Sergio? I think so. All right. All right. So what will we use for tech? We'll use icons for your grades to submit assignments. If I have additional course readings, they'll be up on icon. And I will make course announcements through icon as well, too. So that email you got with this link to come here, that's all icon will do, right? But we're not going to use icon for lecture materials because I use my website, and I also put everything up on GitHub. And I'll give you those. I'll talk about GitHub in just a bit as well, too. So finally, every lecture that we have will be posted to YouTube for posterity's sake, but also to have you cover it again if you need it at any point. I would be happy to, well, if you have any questions about that, let me know. But the YouTube channel, let me double check. I will make sure that we have a link to that somewhere where it's accessible as well, too. So for the most part, then, we'll get into the computing. We're going to use R to access Stan. Those are the two big ones that we're going to do. And R's access to Stan actually uses a third program called CMD Stan R. So it's sort of three modes. The third one, the CMD Stan R, really is like an R package you install. Stan's an interesting program. So what happens in Stan is basically what we're going to do is in R, we're going to write a string of text that has a Stan model. And then we're going to submit it to Stan using this CMD Stan R program. What ends up happening behind the scenes is Stan as a program interprets its Stan syntax, converts it into a custom-built C++ file with linked libraries that Stan installs, and then compiles that file itself. So every time you create a model analysis in Stan, what it's doing is creating a very specific program, executable file, just for that model. So what that means is it provides a bit of efficiency for what you do. There are a number of very general stat programs out there. They are great to be general, but they're also very inefficient computationally. For instance, NL mixed in SAS was a long-running optimizer that you could do multi-level or psychometric models on. It would just take forever to run. JAGS is also very general. JAGS takes longer to run. Part of that is the overhead of the program. To be general, you have a lot of extra stuff going on, whereas what Stan does is sort of cuts out the overhead, builds a very custom-built C++ program for you, but then on the backside of it, it's doing all this. You're not doing this. But then the benefit to it is, in theory, it runs a little bit faster. Now, you may not feel like it actually runs a little bit faster once you actually do it, but it is a bit more efficient. How are we doing? All right. So R Studio, you can put all these programs onto your computer. I will say, depending on your platform that you use for your operating system of your computer, sometimes Stan is easier than others to install. For that reason, our campus notebook site will have Stan, CMD Stan put in it. And actually, our first homework, it kind of ensures that you can do that. And actually, our first homework, I think it'll get you to install these things on your local machine as well. Because part of the fun, if you will, of Stan is sometimes it's difficult to install. The times where it's difficult to install, I would say, are probably if you have a Windows machine, you probably need this thing called RTools to install Stan. RTools you can find from the CRAN website. If you don't have a Windows machine, like if you have a Mac or a Linux machine, generally those have some of the compilers built in, or they're easy to install when R gets installed as well too. So that's all the first homework. We'll get to that in just a bit. So what are we doing for class? There are three things you're being graded on. Number one is homework assignments, which are 60% of your grade. Number two is formative assessments, 20%. And then finally, a course project, which is 20%. Here's your mathematical percentage of how we calculate our grade. And if you'd like the homework points, it's the number of homeworks. Actually, here's the thing about homework. I don't take late homework, but I do drop a homework. So If you are late, I will drop it. Now I say late homework. I have some flexibility, but generally speaking, I'd like you to stay current with the class because every homework is sort of an ordeal to get through. And so if you've got more than one, it's going to be a little bit harder. So this is my formula for dropping a homework, and then HP goes up here into the weighted average. So this is just a weighted average, but there you go. I mean, what class would this be if I didn't have a formula for my grades, right? I mean, I can say it in words, but words can be ambiguous. You put an equation down, and if it's formed well, it's infinite. It's forever, right? All right. Anyway. I like math. Is that coming through? All right. So homework. Homeworks are generally going to be assigned with about 2 weeks before the deadline. So today I'll actually show homework 1 to you. You've got 2 weeks to submit it. It will. It's not going to be overwhelmingly hard. It's going to be one where you want to make sure you go through it because it's sort of the setup for your local machine to have stand on it. The formative assessments are short, a few questions. Somewhere 5 or fewer questions every week. Their purpose is for me to judge how well I'm teaching you material, literally, right? So So here's the thing: you get full credit just for trying, right? So I would prefer you try. You give your honest answer to each of these questions. They shouldn't take long. They should take maybe 15 minutes tops to do. But what I do is I read those answers. Vladimir will lead a discussion about the questions to sort of reinforce the learning, what the answers could be. But then that helps me understand which areas I need to emphasize a little bit better as we go forward or recover as we go as well. So formative assessments are basically free points just for trying. There's no penalty for failing, but the purpose of them is really to help us get better at, help me get better at teaching you during the semester. Cool? All right. Last but not least, there is a course project. There are a couple deadlines I'll go through as we get through the semester, though, so don't note them too heavily now. The course project, the goal for me with that is to take these esoteric examples, textbook examples that are always work well, and transfer that to your data of some sort. Now, if you don't have data, I have a ton of data. I'm happy to share data sets with you. Some of you come in with your own data. It'd be great if you'd like to use some of your data on a project that you feel is important to you, because I think that shows, that gives you a bit more understanding of the method. I think the context of your own data helps a little bit more with it. But if you don't have any data, let me know what you're interested in. Shoot me an email. I can share some data. I can try to find a data set that'll work for you. Now, the type of model I'm looking for is something where you're taking a Bayesian psychometric model. I'll also allow multi-level to be in there as well, and applying it to your data, right? It's basically a data analysis with one or more models that you're estimating in STAN, basically. And so there's a series of dates. Again, much more of this will be handled as we go through the semester, so you don't have to think broadly about this now. But there'll be a small paper, 10 pages or more, with an introduction and the research questions and hypotheses submitted in October. This will help me work with you to build the project itself as we go forward. And then during finals week, we'll have a project presentation, and the final paper will be due just slightly before finals week, which is December 13th. 20 pages or less is what I'm looking for. It'd be great if it's something that you wanted to publish on your own or get started to publish on your own. Again, the topic of it, I'm happy to work with you on. And actually, I view this whole project as a chance to work with you one-on-one to implement your models. Now, some of you may want more scaffolding, some may want less. That's okay. I remember in my last time I taught this, some students I met weekly about their project, and some students I didn't see until just before the end. No, either of those are okay. It's just a matter of what you need. Am I talking too fast? I realize I haven't done this in a while and I feel amped up. So if I'm talking too quickly, got to have that sign for slow down, right? All right. Here are our grade scale, fairly standard. I will tell you this about AI. All right, we all know AI. AI will write you stand code. But that's the purpose of this class. I want you to write your own. You're going to be a better I than AI, right? I want official intelligence, not artificial intelligence. Now, AI will help, but I will tell you it doesn't do great with a lot of the models, and it's usually easy to tell where it happens. So I'm going to ask you to not use AI for your assignments or anything you submit. I want it to be all your own work, mainly because I don't want to train you to use ChatGPT to run your models. I feel like we have a dangerous path forward if we can't understand what we're doing ourselves. And so I want to train you on how to do the models yourself and think it through. Because I think things like ChatGPT are great. They're amazing, what it can produce. But then once you get into the finer details, right, the nuances, not as amazing yet. Maybe one day soon it will be amazing. Not quite for where we're at. So I'm hoping that you'll not use it. Now, I can't police everything, but at the same time, if get that. Anyway, blah, 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 blah. All right, last but not least, a couple important things. If you have a complaint, there's a link to that education website here. There's a link to the policy about academic misconduct, which I assume we will never use this year. And then there's university course policies as well that are on there. They want me to put that into the syllabus. I just put the links there, and here's why. How many of you read the terms and conditions of every single app that you download? Right? None of us are lawyers, but know that they're at the end of the syllabus. Do visit those links. As of when I put this together on August 19th, those links were active. But if you refer to the syllabus next year, they won't be. I almost guarantee it. But all right, that's the syllabus. How are we doing? Any questions so far? All right. Closing the syllabus, going back to our course website. The GitHub repository. So everything that you see on the course website will be available on this GitHub repository as well. If you're familiar with GitHub, feel free to download, clone the repository, work in it. If you're not familiar with GitHub, you don't have to be. Just know that I will simultaneously post links to slides and files, and those slides and files are there. So for instance, the slides themselves are a PDF, are actually an HTML link. There is, actually I use a package named Quarto. So if you want a PDF version of the slides, if you go to click the slides, go to tools and go to PDF export mode, you'll be able to create a PDF of the slides themselves. And actually, if I go into the lectures themselves, there should be a PDF. Yeah, each one has a PDF file in that folder. So that is it. I will say this, if you are into GitHub, be careful, because each week I update the repo with new lectures as I put them online. So that means if you have a local version of GitHub and you fast forward your repository to when I put my new materials in, that might overwrite things that are in your repository ahead of time. So I would be cautioning you about that. Maybe have a separate folder outside of this to do your work. But if any of that makes sense to you, don't worry about it. Finally, and most importantly, the Interactive Data Analytics Service, IDAS, they have a site where we have a class link. So if you click that link right there, or if you go to notebooks.hpc. Now this is the funny thing. Here's the Notebooks website. Our class is below the black banner. So to find it, you can either make the website really, really tiny, or go to our course website and click on this link. Either one of them, it pulls up this page. You go to my server if that's basically it makes you log in. Once you log in, this is what you see. It's an RStudio server. And the files that we have, if you look at our file directory here, under the folder class files, that's the GitHub repository. So everything that's on GitHub is also in our class home in the class files folder. So the syllabus I just talked about is here. You can see the markdown file for it, or you can see the PDF file for it as you go. But just know anything that you personally stash in class files. So if you write something, if you take notes online and you stick it in the class files folder, it will be destroyed the next time you log in, right? So you can use the rest of this folder system. Actually, pardon me. These three folders, class data, which if we have shared data will show up there, which I don't believe we will have. Class files, which is the GitHub repo, and R, which holds our R packages. Don't put anything in any of those folders, but you can create your own folder where you make copies and put that in as well, okay? Big caution. You can, as we go forward, so Thursday you can see our lecture. You can see the PDF of the lecture, which is right here. Or if you're really brave, you can open up the Quarto file and click on render. And what it will do is actually run the file and build the lecture, to which we'll be able to see in the RStudio window as well too. So try to have it all in one place. I will say this, as we get in this semester, particularly when we get to lecture 3, some of those Quarto files will take quite some time to build because it's running analyses in Stan as you're going through it. And so when you run them, it may be 15 minutes. It may be 20 minutes. So just as a heads up, that's why the PDF file shows up in every folder as well, so that you can just go straight into what we do. And similarly, I think the HTML file, if you click on it, should be able to be opened in a browser as well too. So that's my interpretation of course technology, my plan to use it. How we doing? Okay, so a typical class lecture will look like this. We'll all show up, do our Midwestern, how you doing? Sorry, I've lived in the Midwest long enough to be like, yeah, how's it going? You know, good. All right, great. We move in, we jump into our lecture. My lecture will be screened you'll see my screen, you'll hear my voice, and we'll dive right into the notebook site. And in between the lecture files, which should be, or the course, which should be in the viewer here, and then the R files would be on the other side. Pretty much everything will be in the notebook site. That being said, you will also be able to use notebooks for your assignments, for your project as well too. The notebook site allows you to install Stan on it, which is great. The flip of that is, if you have, maybe not for homework, but certainly for your project, if you have an analysis that takes 24 hours. Now, how many of you have run analysis that taken 24 hours or longer? Anybody? A couple of you. Okay. In the Bayes world, it can happen. And if you think that's bad, you should see the early 2000s in my career, right? Very long time to run analyses for models, right? I probably should have not been so stubborn about the theory of the model and found something more practical, but, you know, live and learn. Most of the analyses that you'll do won't take that long. Most of them will take a few minutes, tops. But if you misspecify something, it can take that long. And if you're doing something like that on notebooks, I mention that to you because every once in a while, the server gets reset. So if you can start an analysis, you can close your window, you can come back, it should still be running. But if the server gets reset, if that container that it uses for the RStudio server is destroyed, the analysis will quit and you won't get any output. So just a caution about that. That's where Homework 1 will help you install what you're doing on your local machine. Okay. Am I forgetting it? Vladimir, am I forgetting anything?
I don't think so.
Okay. I think then, let me just double check. Let's go on to homework number 1. This is due September 5th. I'm assigning it today. We'll talk more about it on Thursday. But let me just, since we have a few more minutes here today, basically, I'm going to ask you to install CMD stan R and rstan on your local computer. There is rstan's fairly easy. Unfortunately, rstan is not entirely supported anymore. So I give you rstan because in part, if rstan doesn't install, some of the compilers that you need to run stan aren't on your system, and it's sort of informative. But to install rstan, it works the same way as any other R package. Install.packages, quote unquote, rstan, it installs. CMD stan R takes a little bit more patience. So if you go to the link that I have in the homework, this is CMD stan R. If you click on the Getting Started with CMD stan R, it shows you how to install it. But instead of installing a package from CRAN, what it's doing is it's pointing you to one of the GitHub sites for stan itself. So it's not a CRAN package. It's not like a submitted downloadable R package. It's just something that shows up on stan GitHub or repository. Then once you install the package, you actually have to install CMD stan. That part takes a while, right? What you'll see on your screen. In fact, here, let me give a demo to you since we have a few extra minutes. Anybody in a hurry to get? I'm just kidding. I shouldn't say that. It's the Zoom experience. Hey, I don't want to waste your time, but wait, you're paying for this some way, somehow. So I should give you what you need. So in stan, what you end up doing is you take this first link and you follow along these steps, and I'll just put this. Is the font large enough for you to see on my screen? Can you see okay? Okay, great. So we install the package. Bear with me, I promise this will just take a moment. That part doesn't take too long. I say that and it's paused. You know, 19 years of teaching, and the thrill of the live example I didn't plan for is still going strong. Like, every time I screw up, it's one of these examples where I'm like, yeah, I'm going to try this. I'm super confident in my ability, and then, reminded. Okay, so then you copy this part, which loads it, but even though it's loaded, it's not actually installed. This last two steps are most important. Check CMD toolchain. That tells you that the C++ compiler is built. So if you're not familiar with how programs work, C++ is a programming language. There's a bunch of text files that a program builds. Compiler takes those text files and builds it into machine language executables. A linker puts the files together so they can talk to each other. That's all happening underneath the hood of what's happening here behind the scenes. And then finally, the last bit of it, install CMD stan. This will run, and actually, let's see if there's an option here. This is what it will look like as it runs. It will take some time, and then it'll start putting in compiler messages. And I just wanted you to see this so that you're familiar. I believe that you may have to install this on notebooks as well in each of your notebooks' local sites. So here it comes. Yet again, I feel like I need some music playing. This class needs, or stan, any of you who write, there it is, that's what I'm talking about. This is the compiler working, right? It's moving, it's running, you want to see that. This might take a few seconds, that happens. All this goes on. This is the process of installing stan. It's building the CMD stan R executable behind the scenes. And what ends up happening is it actually shows up in this R library on the main home folder. So yeah, I do believe you're going to have to install this on notebooks as well too. So this process that you do on notebooks should be fairly standard. It's a Linux machine that you're running on, a Linux virtual machine. Whereas on your local computer, again, Mac and Linux will be pretty much the same. Windows may have an additional step or two, but let me know if you have any struggles with it as you see it finish here. But as we wait, as we see this, I actually think Notebooks is taking extra time today because there might be a few more people on the network this morning than normal. Normal being summer or not teaching time. But there we go. This is what running Stan is alike, even though we're just installing it. Because when Stan runs, it gives update messages about how far it's gone, and you just sit there and wait. I just wish it had some music or something it played while it was working. Maybe as it like gets close to the end, you see like faster paced music. Anyway, it's done. It installed. There it is. Now you don't have to do that. Sometimes, every time that you load the library CMD Stan, so if you type the library right here, once it loads, it might tell you your Stan is out of date. There may be a new release of Stan. Basically, you rerun this section again, it updates. It's good. Any questions on what I just did? So the homework, again, and I shudder to think it's not really that complicated. It's more potential for frustrating. Install Stan on your local machine, and then go to IDAS and make sure it's installed. Actually, let me update this to make sure it's installed on IDAS as well. I'll give you the same code. All right, so homework, I'll update this file and send it out to you when we're done. But basically, I want to make sure it's installed on both so you can have access to it. Homework is due September 5th, which should be, we'll check what day that is. That is a Thursday. So a week from tomorrow it's due, which may seem like it's a little bit quick, but I don't think this will take all that long. It'll be very familiar to what you just saw. And if you're wondering how to keep track of what you just saw, there'll be a YouTube link to the YouTube channel you can go back to. Okay? All right. Any questions that you might have? The question was, can we use IDAS or local R? And I'm repeating the question, by the way, because I'm trying to get in the habit of that, so we have that on the recording. You can use either. It doesn't make a difference to me which one you'd like to run. What is better for you is up to you. I made sure that the IDAS site is available because I know that everybody will have access to it. But if you prefer your local machine, some local machines will run faster than IDAS, but it doesn't make a difference as long as you're running the program. As long as you have one method to run it, pick which one is best for you.
Gotcha.
Thank you for the question.
Thank you.
Other questions? Okay, just thought of one other thing I thought about coming here. In-class attendance is not mandatory. I mean that. We're all grown-ups, so you can do what you need to do. That is partially another reason I have the YouTube videos up. So if you're able to make it, it's great. Please do. If you're not able to make it, I understand. You don't need to tell me you're not able to make it. If I don't hear from you and all of a sudden like assignments pass and you're still enrolled in class, I will reach out and see that you're doing okay. I will not nag you. But we're all grown-ups. We all have our own... Sorry, I say that. I have a 9-year-old who is in 4th grade, and we all talk about grown-ups a lot these days. But we're all adults here. We all can set our schedule. But to me, I hope the benefit of being here is you can interact with me a little bit more freely when things come up. But you don't have to. There's always email. There's office hours, and there's other ways to get a hold of me as well, too. All right. I don't think I've missed anything. And Vladimir, you tell me. So... all good. All right. I'm going to stop here. I will remind you tomorrow morning at 10 a.m. to noon is my office hours. 9 to 10 is Vladimir's office hours. And so you've got 3 hours of access if you need it. I doubt you will. I would encourage you to try to run Stan as soon as I update the homework file, which will come out in just a few minutes. Okay? All right. I look forward to teaching you this semester, and I hope it's worth your time to be here. So thank you for being here the first day. And any questions, comments, or concerns, I welcome them. Just send me an email or come to office hours. All right? At that, I'm going to stop lecture. See you later. Have a good rest of your day. Yes.
Sorry.
Oh, sorry. Before we go.
1 minute after
Yes.
class?
Oh, yeah. Yeah, no problem. All right. See you, everybody.